Okay, just so you guys know, we're trying out a new format for the Apache Geode Clubhouse. Welcome everybody. We're playing with Adobe Connect for hopefully a little bit more of a clubhouse feel and a little bit less of a lecture style. That doesn't mean that we are going to deny you a educational experience. William Markito is going to talk about his work with Docker for Apache Geode. So we'll switch to that in just a minute, and then afterwards we'll ask all the committers that are able to anyway to join us on camera, and we'll do a Q&A, and we'll discuss some key juras and some other things going on with the Apache project for the next couple of weeks. So with that, William, we're going to switch to presentation mode.
Okay.
Let's see, as we try to learn how to work on this thing. That goes to sharing, right? Okay, good.
Okay.
So,
Good.
William, go ahead and share your screen, and
Okay.
go ahead and take over.
Okay. Can anybody see my screen?
Yep, we see you. Looks great.
Okay. Excuse me. So, Geode and Docker. The idea here is to discuss a little bit of the work we did around containerizing Geode. Before I start, actually, I should put this disclaimer here. Since we are part of the ASF incubator and we had not yet a release, the current bits available in Docker Hub, right, and as a nightly build, they are for development purpose only, so use at your own risk. But I can assure that it's a fairly stable code base given the many years we spent in development of in the project, right, as Gemfire. So that said, here's the proposed agenda, which is not here in the agenda, but it's also part of this conversation is, of course, Q&A in the end. But the idea is to cover a little bit about Docker basics. If you are already an experienced Docker user, this part may not be that interesting for you. But the part about Apache Geode and how we do some use cases with Geode and Docker, that may be more interesting, right? And then some troubleshooting and some general best practices around that we discovered while building our image. This is an actual picture of me. This would make more sense if I hadn't to use my camera. In fact, I have a slightly different picture, but I'm an enterprise architect for Pivotal Gemfire. I like to say that I'm helping customers and field design Gemfire solutions. I also like to say that I'm helping engineering with features and bugs. I'm not sure I'm doing that, but I hope I am. And I'm also, of course, focusing on Apache Geode and the growth of the community as well. Here is a picture that I'm sharing as the enterprise in the next year, although this is already happening, I'd say, nowadays. But imagine that next year things may get even more confusing if you are not familiar with containers and how to deal with containers in your architecture, right, in your system, in your company, because the growth of Docker and how Docker Hub is making images easy to share and available to everyone is a fact. And the whole idea here is to just be prepared that, well, if you don't really prepare and organize your containers in a system, you may see a very similar picture here, but just running in your production environment. Before I start talking more about containers, I'd like to start about the history a little bit here, since everybody or a lot of people think that Docker is all this new technology, right? And it is indeed new. The project actually was made public in 2013, but the whole work around containers started in FreeBSD around 2000, right? And then, of course, we had Solaris Zones 2004, which was another implementation on top of the FreeBSD concepts and ideas that already made it simple to create isolated environments on top of a single operating system, right? But the real difference here with Docker, of course, is that Docker made it very, very easy to do. And the tooling in the ecosystem around Docker is what makes it that interesting today. So why use containers, right? One of the first and most important things is that you do have a very, very fast churn when dealing with containers, especially when you are comparing with VMs, right, with traditional VMs. Even the most fastest hypervisors will still take a couple minutes, I would say, to start an operating system, right, to start a VM. And with containers, we are still, even if you made the most worst or the worst possible container, you'll be talking about milliseconds in order to start this container, right? So that's one key difference and one important thing about containers. And that also applies to shutdown and stopping, right? So it's very easy and very fast to start and stop those containers. For applications, it's seamless, right? It really, for the application, you do have your own file system, you do have your own memory, you do have your own CPU, and network, you kind of have your own, but it's also, for the application, it seems that you have your own, but you are still sharing some of your host infrastructure, of course. It's also a nice way to keep your environment consistent, because when you are dealing with containers, right, you are shipping not only your application, but also your dependencies. And that's interesting because you can also leverage that in order to troubleshoot and see what exactly in production, for example, if you are experiencing a problem in production, you can also see that in tests and CI as well. You can leverage the containers in order to run all your tests and make it part of your build process. And these three companies here, right, are of course nowadays good examples, and I would say the best examples of containers used in large scale, right? Google, Twitter, and Netflix, and many others, of course. But these three, I think, they are leveraging containers heavily to scale their production systems, right? And that's a nice way to say that. Well, some people still think that containers are not production ready, right? But I guess leaders in this space are kind of showing and proving that that's actually ready for production. I'm going to quickly just touch a few points when comparing containers and VMs, although this may be obvious if you are, as I said, a container expert. But when comparing with VMs, right, I like to this phrase here that actually summarizes what's the difference, right? While the hypervisor abstracts the entire device, containers just abstract the operating system kernel, right? So in the end of the day, when you're talking about a container, you're still sharing that host kernel and just virtualizing the operating system, right? While with the hypervisor, you are most of the time just actually virtualizing hardware, right? So those are pretty much addressing different concepts and different problems. Another common comparison here is with Vagrant as well. And it's really not a fair comparison because everything we just said about VMs is still apply to Vagrant, right? Because in the end of the day, Vagrant is still managing VMs, right? While Docker is all about containers. So that's also, so everything we said about fast churn, for example, with Vagrant, you're still talking about few minutes. When you are downloading or sharing a Vagrant image, right, you are sharing a VM, so you may still be talking about a gig or 2 gig, or depending on the size of your VM. While with containers, you may be talking about a few megabytes, a few hundred megabytes, right? But one interesting thing when talking about Vagrant and Docker is that both use a descriptor that is almost, I mean, it's quite similar in a sense, but if you look at the syntax, the Docker file seems much more clear, and the concerns about them also, I mean, the concerns they address are slightly different, right? Since you are still provisioning a VM with Vagrant, right? You still have to take care about, for example, setting up network and stuff like that. While with Docker, you may kind of not need to do that upfront. Just a quick list of commands. This is really just for reference. If you are downloading this presentation after and you want just a quick list of the available commands. So with Docker, of course, you have a lot of options to do actions and start, stop, kill, and attach and whatnot with a running container. And you can also, of course, monitor. There are many commands available to monitor containers. And when managing images, also, of course, you can still you can build those images and share and import and build and whatnot, right? This link here, I guess, it provides a complete set of instructions, even better, I would say, than some of the Docker documentation. So let's start taking a look at our first Docker file here, right? So this is a very basic one. In the end of the day, the Docker file is really just step-by-step instructions describing what's exactly going to happen with this container, so what you are building. The outcome of this build becomes an image, right, which is then shared, and it's a read-only image that once you run it, then you have a container instance, and the instance then becomes writable, right? So just to start, I'm going to build this first container. Is the font size good? Maybe I'll just increase it a little bit. Okay. So
yeah, William, it's just a tiny bit tiny.
okay.
Granted, all of us should be watching it full screen, which would be better.
Okay.
Yeah, but as long as you know, as long as you're not on too small of a screen, it's reasonable.
Okay. I'm increasing the font size here. Good. So now, of course, that I have cached here this image yesterday, but that's pretty much what you're going to see. So you see all the steps described in the Docker file, and then the outcome, which is this hash, which is just the image ID. Here we can see the image size, when actually it was built. So this is also one interesting concept about Docker, right? I'm building it again, but since it understands that, well, this exact same image was built yesterday, I'm just giving you the same one I built like yesterday. That's nice, because if you are sharing those containers, right, with others, it makes it easier to reuse what's already built. So that's very simple, nothing really major. Now let's execute this container. So since this container has just pretty much bash, and I have just installed a Dust Unix library here, I can run it like this. Oops. And while I'm running here, I'm passing this -it, which just means that I have an interactive shell and a terminal available in this container. So here I'm already inside this instance of the container. As you can see, every instance has a different ID compared to the one we had before. So here is the image ID, and here's the container instance ID. And as you can see, it takes very little time to create a new one. I'm creating, as you can see, many instances here. And if I do a Docker PS, now I don't have any other container running, right? That's fairly simple, very introductional, right? Okay. So still talking about some of the concepts around Docker and the Docker file, right? Layers are one of the very important concepts, because they can save you and they can ruin your image pretty much. And I'm going to demonstrate that. But the whole concept of layers, right, is based on another, again, old concept from FreeBSD named union mount. And the idea is that you can pretty much share multiple directories or file systems or different file systems and mount them as a single mount point. So for who is consuming this file system, it appears to be a single one, but it's actually a combination of multiple layers or multiple directories or file systems, right? So for example, in this image here, you have the base image, right, which is just a Debian-based image, and then you add Emacs, or then you add Apache, right? So these two are different layers, and then you say, okay, that's it. That's my container. So when Docker provides you a container instance, then it provides you a writable mount point on top of those layers. So why that's actually interesting, right? So for example, here, this image we just built, it had 236 megabytes, right? And you can see more details about it using this Docker history and passing the container ID. So now, as an exercise, let's just install a simple header file that actually has 49K size, right? I'm going to do that now. Actually, I had it here already. So I have two instructions now. So one, I'm installing .unix, and the second one, I'm installing the zlib, the header file. Okay, so here's our new container or image ID. So let's see what's the size of the image. Well, almost 300 megabytes. So we just added a 49K header file, and we increased our image from 236 to almost 300 megabytes, right? So what exactly happened here, right? It doesn't make any sense, right? So what happened is that given that we added that instruction in a different run command, you actually created a different layer, a new layer, right? So instead, if I just reuse, of course, that in the case of Yum, it's fairly simple and it's very intuitive that you can actually just, for example, right, set the instruction in front of it. But there are other use cases, and that's the whole point of this exercise. So for example, here, I'm fixing that and just using a single line. And then if I grab the size of this image, that makes more sense, right? I'm just adding a few Ks and not actually another 40, 50 megabytes, right? So the whole idea of this exercise is to explain the Docker file for Geode. Here's the complete Docker file for Geode. And as you can see, we actually try to keep everything as part of a single run instruction, right? And in order to do that, the syntax may not see or may not look that nice, but the whole idea here is to avoid creating a bigger image, because in the end of the day, when you are sharing or using those images, you want the size to be the smallest possible, right? So for example, in the first exercise of building the Geode image, right, we were using separate run instructions for a couple commands here, and the result was an image with almost 2 gig. And by making everything inline in a single instruction, we could make it available as 400 or almost 500 megabytes. So it's more than 100% improvement. So it's really interesting. As in order to show that, oops, let me just grab for. So there you go. Here's the size of the Geode Docker image, right? So instead of sharing something with a couple gigabytes, we are sharing something with megabytes. So that's That's important when you're talking about containers, because as I'm saying, you'll be sharing this and reusing these images when you're building applications. So saving network bandwidth is good, right? The other interesting concept that I'd like to talk about Geode and containers is how to create a cluster, right? And at the end of the day, to create a Geode cluster, you may still want to, of course, have a locator and a server. But if you do that manually, in instantiate, for example, every container and try to make them see each other doing the linking and whatnot, that may not be that easy to use, or you may actually need to remember all the syntax and all the commands available. So in order to kind of save you some time, there is this other tool available in Docker, which is named Compose. And it's a simple YAML file that you can use to orchestrate multiple containers, right? Here I have just an example, just a snippet, right? But that's actually the whole file to orchestrate a Docker, a Geode cluster. And that also allows you to scale every node here, every service as they call it, and also to do the network wiring, because there is a link instruction, and let me actually show that in a text editor, which I think it makes more sense. Hope the font size is good, otherwise let me increase that a little bit. Okay, so here I have this link, and what this link does is pretty much provision inside the server container, inside the etc hosts, the IP address for this locator container, right? So you have two different containers running here, but they can see each other through the network, and they also know each other through a configuration in the etc hosts. Another interesting thing about Compose is that you can limit resource usage. So I'm saying that, well, this container here has only 2 gig of size. And since for the locator, I don't need that much memory, right? I'm giving it a smaller container instance. Ports also, I can decide which ports I'm exposing and to which port I'm mapping that in the host, because in the end of the day, you may want to expose those ports and you want the ephemeral port in your host to be known, right? And the image here, as you can see, is the same geode image. So let's run a demo with that. So here I have my Docker Compose file. And you can run it by executing Docker Compose up. Now it's starting the locator. And in this particular case, it's already starting 2 servers. I'm going to explain why. Since it's providing also, doing all this wiring, right, and setting all the network and provisioning all that, it may take a little bit more time than what it would take for running a single container. But that's because, of course, you are providing and doing all this link, like you're provisioning all these 3 containers at the same time. Okay, so now on this other terminal, I can do a Docker PS, which is just a way to check the containers running. So here I have the container ID, the ports they are exposing, and let's try to run gfish. I'm connecting now inside the geode locator container, and I just got gfish. I have connected, and now I can list the members. So as you can see, I have 2 members. And just to make sure it's a fully operational system, right? I can create region, my region, type, let's say, partition, right? So that's good. Now, one interesting, and I think one of the most interesting concepts of Compose is that I can scale. And remember that when checking the syntax here, this server and this locator, they both got used as part of the name of the container, right? So I can ask to scale the server by just doing scale server equal 3. Okay, let's see if that worked. List members, remember that I had 2 before. Now I have 3. I have a third member. And that's also one of the interesting part that make Geode a good fit for containers, right? Because since it's really easy to add more nodes to a Geode cluster, as soon as you are providing those containers and they are joining our distributed system, right? Regions and data, they are then available and could be spread and balanced in the case of, for example, a partition region, right? Or even in the case of a replicated region, of course, you can have the data spread among all other nodes, right? And if, for example, for example, since the containers, they are so easy and as they say, they are easy to be added or removed, or that you shouldn't be caring that much, I would say, about some of the health of your containers because you can pretty much kill them easily. Given that you have enough redundant copies in your region, right, for Gemfire or for Geode actually, that's fairly simple then to scale because you're not losing data because you have enough copies, right? So scale can of course make it scale up and down. Now I'm just scaling down. I'm asking to keep only one server. Okay, it may take some time for them to leave our distributed system. There you go. Getting back to the slides. And then, of course, we can talk more in the Q&A and have questions about it. So Geode on containers, right? So there are many use cases that make it interesting for Geode. Of course, that since Geode is pretty much designed to scale, right, and containers as well, so they made a good fit because, of course, if you have a microservices architecture, or you want to just scale those applications or services running on containers, right? It's fairly simple to do that. Also, if you want to just test or reproduce some production scenarios, right? For example, network partitions, right? If you're familiar with Japson, for example, that's also one easy way to test network partitions leveraging containers, right? In the case of Japson, they use LXC containers. I mean, one way to do it is using LXC containers, but you could also do using Docker as well. And it's also an interesting way to deploy on cloud infrastructure, of course, because, well, most of the cloud providers nowadays, they also run containers, right? So if you're talking about Amazon or Cloud Foundry or any other, but here, the entire demo I did until now, of course, it's running on my laptop. But if you want to run containers and manage them across multiple machines or even across multiple data centers, right? There is, of course, still the need of to use a platform so you can actually monitor these containers and capture logs and check the health of all these containers and understand and see, oh, okay, so one container died here, so I need to restart, or can I restart given the current status of the system, right? That's also another technique called like circuit breakers, right? That some solutions and some platforms provide. So here I'm just sharing a couple examples. Of course, Mesos, which is heavily used in Twitter, Kubernetes, which is pretty much a equivalent, I would say, solution for provided by Google, right? And Cloud Foundry as well, of course, can run containers, right, as a first-class citizen. And then Docker itself provided, and there is a tool named Swarm, which is this logo here with the whales, and that's also a Docker alternative to run containers across multiple machines. As part of the Docker ecosystem, right, of course, there is the Docker Hub, and here's the URL for our Docker Hub. And it's nice to talk about Docker Hub because whenever you are running and building your containers, right, you may still want to, for example, host your Docker file in a GitHub. And then if you do that and you have an account with Docker Hub, you can just integrate both of them and ask Docker Hub to build the container for you. So Docker Hub is pretty much sharing storage and infrastructure to run and build your images for free. There is a pending Jira that I'm about to merge to actually make our Docker fileable as part of the Geode source code. And then as soon as that's provided, we are going to integrate and make automated build in Docker Hub for the Docker images of Geode. So talking a little bit about troubleshooting, right? I guess this image nowadays is becoming very popular. I'm pretty sure that the guys that when the accident happened in 2007, they were not really considering that we are going to use this for IT or how we are using this nowadays, but it's becoming very popular, right? So when you are troubleshooting containers, we're pretty much talking about two different status here, right? One is, of course, the post-mortem. So the container is already dead, and you want to understand what happened. So three techniques that I'm sharing here. There may be others, but these are the three that I like it more. So of course, when you do a PS, and let's start a little bit with our demo here to make it a little bit more hands-on. When you do a Docker PS, you just see the running container, right? In my case here, I don't have a running container. But if you do a PS -A, you actually see the history of all the containers that you executed, right? And that's also interesting because people tend to say that when the container is gone, you just lost your state, so you lost your logs and you lost your data. But that's not entirely true, right? So this history here, it's still accessible and you can still log in, and depending on the way you set up your container, you can still start it. So yes, -A, it's a nice way to do it. You see that you check the containers, and now that I have those IDs of the dead containers, I can inspect them. For example, let's inspect this one. So here is all the metadata available for this container. Let's scroll up a little bit. Here, for example, I have the state section with exit code, and if you have thrown an error, right, as your foreground process running in the container, right, you would see the error message here, and you can check when the container started, when it finished, what happened, what was the network configuration when this container was executing. If you had volumes mounted, right, which is something that I also really advocate to use, you can also see where exactly those volumes were mounted, right, and where in the host they were mounted to. If it was read write or just a read-only volume. So all sorts of metadata are available here, including CPU shares and memory and whatnot, right? I also, as I said, I advocate for the use of volumes, right? And in my case, I'm mounting here all the volumes as data inside the container, as slash data, actually. And here, for example, since I'm using the host name of the container as the ID of the server, you can see the folders here. And now, as you might imagine, I still have the logs available. And then I can troubleshoot as I would do, right? Here's just a Gemfire server log, or Geode actually. So, and this container, as I was explaining, right? This is post-mortem, so this container was already gone. But of course, you can still troubleshoot an online container as well using stats, logs, and just plain bash, right? So as an example, let me start our cluster here again. This time I'm just starting one server and one locator. Let me check if there is any pending questions here. Oh, yeah. Okay. So Docker PS, I have server and a locator. And previously, right, I have executed gfish, but since in the end of the day, this is a Linux box, right? A small one, but a Linux box. I can still execute bash. And there you go. Every or almost every knowledge you had about troubleshooting a Geode cluster or Linux box, it still applies, right? I'm inside this machine and I can, for example, check the locator logs and, well, let's see what happened with this locator. Oh, okay. It started, it's listening on this port here, of course, for pulse. There you go. You can pretty much leverage the current knowledge you had about troubleshooting a Geode cluster the same way you would do if it's running on bare metal or in a virtual machine, except for one thing that I'm going to talk about in the next slide. Oh, I forgot to talk about stats. So let's do that. So in order to run the stats, you need to pass the container ID. And these are live information. This is live information from the container, right? So you have the CPU usage, memory usage, and network, right? And as I'm clicking here, actually, it's capturing more data. It's changing a little bit, of course. And another nice way, if you have multiple containers running, to do is execute stats and then just do a PS, because then I'm pretty much passing all the IDs of the current running containers to stats. So you have, in this case, of course, 2. So, for example, we can tell that this is the server, right? Since all our servers have a 2 gig limit. Every time I click, it keeps printing the stats message, right? And you still have, last but not least, the logs. But the logs, they are kind of tricky because in our case, we are storing the logs in the log files, right? So that's why I'm saying that I advocate the use of volumes, because also you keep the logs available in the host and you can troubleshoot from the host. But if you are printing your logs to the output, right, to the foreground of your process, you can do the Docker logs and just check the logs from this command without actually entering the container. I think there's another question here, maybe. Is this top? So it's not exactly top, but it's kind of a top for Docker, right? For containers. So you can see the resource usage for containers, and it's quite funny if you think about it, because you have top and you have, in this case, stats, but you do have Docker PS, which you can argue that it's kind of similar to a Unix PS, right? Moving on. So concerns, right? Of course, that one of the main concerns around containers is performance. And as a tip, I'm already saying that if you're running and measuring performances on containers, please use this --net equal host in order to use your host network and not the virtual one. And that only by doing that, you improve a lot your network performance inside containers. We can talk about more details later if you want. Storage and persistence, of course, that's also a concern, because as I'm saying, as I said, a few people think that depending on the way you do your containers, right, everything that happened inside that instance, once the container is dead, it's gone. But that's not entirely true, right? You can actually restart a dead container if you want, or if you are leveraging volumes, right? As I'm saying, logs, and in the case of Geode, persistent files, right? They're still available in the host, so you can still use that to do backups and imports and whatnot. So in statistics, right? If you are already familiar with Geode or Gemfire troubleshooting, you know that we use a lot of statistics, and we do use and read some of them from /proc, but that's not containerized, right? So if you're running on a Linux box, that for now, it's still not containerized. So some metrics may be still a little bit confusing, right? So that's the only part that I was saying, that if you're troubleshooting a Geode cluster on containers, and you are familiar with troubleshooting Geode clusters, that's the only part that may not actually apply as is in a Linux box. But they are working. I mean, Docker guys are working on some ways to kind of expose some metrics as /proc. And we may also be thinking about something related to that. And of course, fair access to the system resources. So you may still have concerns that if you don't specify proper limits to your container instances, you may, some containers may be just stealing resources from others, right? But I'd say that depending on your VM hypervisor or the way you are provisioning VMs, that problem may still apply, I guess. But as I'm saying, it depends, right? And security is one of these biggest concerns, I would say, because there's this idea of everything running as root, and although that's the default in the recent versions of Docker, right, you can actually specify a user for the process you were starting in the container. So that may not apply. I mean, it depends on the way you are running that. And of course, people tend to think that VMs do a better job here. But as I'm saying, it always depends on the solution. Conclusions, right? Speed and ease of use always wins. What I mean is that containers are becoming widely popular because they are very easy to use. I mean, the technology to do and to play with containers, as I showed, I mean, in one of the first slides, was already available since FreeBSD since 2000, right? And then Solaris also had the same, pretty much the same solution available and the same concepts. But they were not that easy to use, right? And they were not exactly available for Linux. So since Linux, of course, is much more popular than FreeBSD or Solaris, right? If you think about it, making it available to a popular platform, making it easy to use, and giving the speed of containers versus VMs, you can kind of guess, of course, why they are winning when comparing to traditional virtual machines. Also, the portability and consistency for different environments, right? For example, as soon as I provision my VM and I'm sharing my container, and I'm sharing that container with dev or with prod, if I want to reproduce something, I can reuse the same image, and I'll be sharing all the assumptions and all the dependencies and all the libraries of that entire host. It's not that, I mean, it's a way to end with that problem that, well, it works on my machine, right? So, well, it works in your machine, but for example, if you say it works in this container, or if I'm having a problem in this container, I can reproduce pretty much as you are running into the issue and leverage all the the libraries and the dependencies you may not have set or may not be using or may be using to cause the problem, right? Another thing is that people tend to say that containers are good for applications, but as you can see, Geode here is being used as a service, right? And they are actually good for applications and services as well. But it's easy to scale for most of the applications. Nowadays, of course, we're talking about stateless applications most of the time, 12 factors, right? Application, as if you're familiar with this concept. But for services such as Geode, it's also fairly easy, right? And I'm just advocating here, just giving it a name. I would say that Apache Geode, you can be used as a cloud native. Since you are talking about cloud native application, right? You can use Apache Geode as a cloud native data storage, right? Since it also can scale with our containers. And now just talking a little bit about our community. We are, of course, looking for contributions. And I like to show this slide because it shows that all contributions don't need to be code. You can contribute by helping us with the documentation, with code, of course, but also with the community, right? By just participating, by just finding bugs, filing bugs, joining our discussions in the mailing list in ASF, or even by just testing, right? Downloading our nightly builds and testing, playing with our code. I mean, we always welcome that. And now I'll open for Q&A. Let me get back to the Adobe thing here.
Thank you very much, William. That was great. And if there's any questions, I had put in some questions there into the Q&A box, but along the way, you actually managed to answer both of them. Any other questions? People can type into the chats, or feel free to enter a Q&A box, or if you're one of the presenters, feel free to drop in on camera and or unmute and ask a question. And William, why don't you come back and show us your mug? Oh, you dropped out, William. Okay, hang on. All right, you're back up.
Wow, okay. Can you hear me now?
Yes, you can. Why don't you join us on camera too, unless you need to go back to a slide.
No, not at all.
And you got a couple good questions in here.
Okay. So, okay, the first question here from Bruce. I missed how you expose ephemeral ports. Okay, so let me share my desktop too. Greg, can I still share my desktop using this?
Yeah, you can. Just let's see. How do we switch this?
I have to put a share pod. I can put a share pod here. We can change the layout.
Yeah, we're still working on learning how to do this. So go ahead and show your screen.
Sure. Okay, great.
It's one of these incredible platforms with so much power that you got to just know which switch to hit.
So in the case of the Docker or the Geode cluster, right, answering the first question regarding the ephemeral ports, in fact, the membership is being established using the virtual network. So okay, here it is. So all the servers, they are talking to each other using the virtual network. So the only ephemeral port for the server that I'm actually sharing is 8080, just for our REST API. So they're still using the virtual network for that. Does that answer your question, Bruce? Let me try to get back to that. Oh, here.
And then you gotta,
Okay.
and then your next question, Bruce is asking, is the
Yes.
virtual network is shared?
Yes, yes. And if you do specify that minus minus net equal host, then you are sharing your host network as well. Greg, you are requesting access to, okay.
No, I just took it back.
Okay.
My
Yeah, I'm
power.
not sure. Things are just moving around.
Yeah, no problem.
Okay. Just moving to the next question. So Ashwin, have you developed scripts or tool for connecting geode containers across physical hosts? So across physical hosts. So for that, actually, you would be using something as Swarm, which is a tool available as part of Docker ecosystem. But you can also be using something as Mesos or Cloud Foundry as well in order to share, to leverage containers and to scale containers across multiple hosts.
All right. And Constantine's asking,
Yeah.
average overhead of Geode inside Docker, inside VM on Mac.
Right. So I still have to run some benchmarks against that. I would say that I would actually prefer to run it running on Linux, because in the case of a Mac, since Docker is pretty much designed for Linux, right? When you are running containers on a Mac, what you are actually doing is you have you bootstrap something. For example, I can, since I'm sharing my desktop still, I guess. Am I sharing my desktop still?
You are again.
Okay. Yeah. So let me try. Okay. Share my screen. So on a Mac, what you actually do, for example, in my case, I'm using this KitNect, which is just a tool that you can that boots a small Linux VM that allows you then to run the containers inside this Linux VM. Because Docker, if you think about it, since it's designed for Linux, right, you can't really run it native on a Mac. But we definitely have ideas and plans to run a benchmark and compare against bare metal and against VMs. But from what I could tell, I would say you may see some hit, but a very minimal one, I would say. For example, if you are using sharing the network of the host, depending, of course, on the size of the cluster and the network configuration of your host, that may be minimal, right? Let me try to get back to the question now. Okay. Does that make sense, Konstantin? As soon as we have this benchmark, we plan to share the results.
Yes, Constantine, we promised low
That's right.
overhead.
That makes sense. But that's the same, I'd say, with VMs, right? One bit that when we are comparing hypervisors, right, or traditional VMs with containers, that we tend to say that containers are more efficient, is that you can fit more container instances and leverage and use more all the tuning, for example, that you did for your host environment. While if you're running a full VM, you may still have to turn like that particular host itself that has the VM, right? So that's also, I mean, a different kind of way to think about it. But definitely, I would say that we may have more information as we run benchmarks. Sure. For development, Konstantin, I wouldn't really worry much about it. I mean, for development purpose, as you can see, I was kind of doing video and starting 2 or 3 nodes of Geode. I mean, fairly fast, I would say. And I can even turn a little bit more the VM that's hosting Docker if I want. Because if I actually, yeah, but without data, yeah, I agree. Yeah, yeah. But as I'm saying, I mean, for development, I would say that it's fairly fast, even with data. For this demo here, I don't have data, but there is another, and I can share the video actually of the stock prediction demo, which is a more complete solution running Spring XD, Geode, and R, which has data as well, and we are running all that inside Docker containers, right?
We're unmiking or miking up Constantine in case he's got a couple of questions he'd like to ask verbally. You
Sure.
guys have a good discussion going here. At some point chat breaks down. So Constantine, can you hear us? And he may be having to reboot his bring in the plugin if he doesn't have the plugin. So
Can you hear me
okay.
now?
Hey, yeah, we can hear you now. Welcome, Constantine.
All right, hello.
Hey.
Hey, I still want to get some idea about overhead because for the starters and hello world type of projects, it's all well, but when we're talking about reproducing issues, we don't, the container and configuration just not enough. We need a data.
Right. Well, if you are using volumes, for example, right, your data would still be external to that container, and then you could still share that and import when you are reproducing the issue in your host. But I agree with what Anthony is saying here, that actually, if you think about VMs, most of the time you are having overhead in the network. So you may have a hit more on the network than on resource like CPUs or memory usage actually. But your mileage may vary for sure.
Yeah, well, in my experiments a while back, running on a single VM, VMware, the system took a hit about around 40% plus.
Wow.
So it was way slower.
Yeah.
Again, might not be a big deal. It's just, you said that speed is a king and convenience is the king. So if it's not fast enough for developers to operate something with the real scenarios, then why bother?
Yeah. Yeah. Absolutely. But I would say that as part of GEM for our customers, of course, we do have many customers running systems using VMs, and whenever we see problems like that oh, maybe the performance is dropping, right? Most of the time, it's just a matter of like having all the proper settings on the specific hypervisor being used, right? I mean, if it's VMware, you may need to set some settings.
Unfortunately, I know
then,
that really well. We we are customers, and if you recall, we were working pretty extensively, and we encountered nasty issues because of our container configurations.
Right.
So
yeah, but
I don't mean to cut off our conversation here, but we are up towards the end of our toward the end of our hour. So to anyone, any of the other contributors, Anthony or Kirk or Bruce or William or Ashwin, is there any last thing we need to bring up in general to the community for the last minute we have? We're also going to be having another more kind of general open topic in about 2 weeks where we can just cover more basic issues like open juris, but this is your chance to kind of bring up one last general issue. Anything that anybody wants to bring up? All right. William, thanks for a very good presentation. Constantine, thanks for the very good brief discussion. We didn't give you that much time, unfortunately. And everyone, we'll see you back here at 9 o'clock in 2 weeks. Thank you all.